Triple extension is a core biomechanical concept that provides the body with the power and support required to perform explosive movements in activities such as running, jumping, and throwing. Triple extension refers to the simultaneous extension of the ankle, knee, and hip joints to generate force and propel the body efficiently during movement. In this analysis, exemplar and non-exemplar running performances will be compared to demonstrate the impact of effective triple extension on running efficiency, acceleration, and force production. The triple extension movement occurs when the ankle, knee, and hip all extend simultaneously to send the body forward. Newton's third law of motion states that for every action there is an equal and opposite reaction. Triple extension puts this law into practice, which we can see in this diagram. As the foot becomes planted on the floor, a large amount of force and shock are absorbed across the lower half of the body, specifically in the ankle, knee, and hip joints. The triple extension, however, occurs after the initial shock absorption, and the energy is transferred into force, which is used to spring the body forwards. Each of these three joints contribute differently to the transfer of energy within the triple extension. The ankle pushes down on the floor through plantar flexion, generating force. The knee provides stability and power, whilst the hip sends the body forward, generating speed and acceleration. We can see the principles of effective triple extension in practice when analyzing the exemplar footage. According to competitive edge physical therapy, when the joints synchronize efficiently, the body is able to generate more power per step, resulting in less energy being required to propel the athlete forward. In the exemplar footage, the ankle, knee, and hip joints can be seen extending simultaneously, with each joint aligning in a linear fashion during the push-off phase after each step. This alignment in the primary joints allows force to be transferred efficiently across the lower body and into the ground. This is an important aspect of the triple extension, as it allows for the propulsion and the acceleration of the movement. The exemplar footage also shows us the athlete utilizing each joint effectively, specifically the extension of the ankle with the toes pointing downwards, the knee providing stability to the upper body, and the hips sending the body forward, all of which are working together to allow the athlete to reach full extension. Through fully extending, the athlete can now generate more power, leading to longer strides, greater speeds, and more efficient energy consumption. The triple extension being demonstrated in the non-exemplar footage shows us how poor execution can result in increased energy expenditure, making running more fatiguing and potentially increasing the risk of injury. Unlike the exemplar performance, the non-exemplar subject doesn't reach full extension in the push-off phase, with the ankle, knee, and hip not aligning. This misalignment can be seen in the knee joint, which remains bent throughout the movement. This limits the amount of force that can be used to propel the individual forward. This bend in the knee is causing the individual to use more energy to maintain speed, leading to increased fatigue and slower movement. The non-exemplar footage also shows the individual generating force upwards rather than forwards. This vertical movement reduces acceleration and limits stride efficiency because the force produced is not being directed effectively in the intended direction of motion. Common issues in the execution of triple extension include incomplete joint extension, poor synchronization between the joints, and inefficient body positioning during push-off. When comparing the exemplar and non-exemplar footage, these differences in technique become clearly visible through the reduced joint alignment and decreased forward projection seen in the non-exemplar performance. Exemplar and non-exemplar footage demonstrates the importance triple extension has in the context of running, as it not only improves increasing the length and power of each stride, it also supports the basis of sending the body forward. Training individuals in performing triple extension correctly can correlate in improved performance over all contexts. De Vries emphasizes the importance of transferring learning from concept to context. Therefore, through learning how to correctly perform triple extension in running, students are able to transfer this movement concept into other contexts such as sprinting, jumping, and the wider sporting environments like volleyball or basketball, where explosive lower body movements and force production are also essential.